is in the form of compressions and rarefactions. Now, when the prong of the tuning fork moves inwards, okay, when it moves inwards, like I'm moving my mouse inwards, okay, when it moves inwards, the air molecules get compressed in between these two prongs, and then the air molecules basically are trying to spread out now, so then it will move outward. When it moves outward, it causes the air particles to compress, and that causes them to bring back, and compression and rarefaction series is created. So if you read this paragraph very carefully on page 255, last paragraph, you will pretty much understand the concept of rarefactions and compressions. So the regions where the molecules spread out are called rarefactions, and the region where they are compressed are called compressions. Compressions and rarefactions take place in the material medium. Okay. Now moving ahead to book page number 256. The sound travels through the air in a series of compressions and rarefactions as the object vibrates until it reaches the ear. Now you have to understand that air molecules themselves do not move from the source. The ear passes this information to the brain. Okay. Now sound travels in the form of waves, and those waves consist of compressions and rarefactions. Without the molecules or particles, the sound cannot travel, and that is why the sound can travel in a medium, but it cannot travel through a vacuum. Okay. Now moving ahead, we will go and the next paragraph of your book. Sound travels, of course, faster in material mediums which are more dense because the particles are closer, and as we move from solid to liquid to gas, the particles move far apart, causing the sound propagation or sound speed to get low. So since the particles in the solids are more closely packed than those in liquids and gases, sounds therefore travel fastest through the solids, followed by the liquids, which is second number, and then the third turn comes of the gases as per the speed, which have least densely packed particles. Sound travels in approximately with a speed in air as 343 meters per second, okay, and 1482 meters per second in water, and in steel or in solid 5960 meters per second. And this is all at 20 degrees centigrade of temperature. Okay. Another very important figure over here of 11.5 that I will explain. Now this is basically a glass jar, and you have placed a bell inside it. Now when the bell is going to ring, you can hear the bell outside over here. Okay. Now we will start pumping the gas or air outside. When we start pumping the air outside this jar, you will start hearing and understanding that the sound of the bell starts to become very, very less. This is because as I'm pumping the air out, the vacuum is being created and the particles are getting less for the disturbance to pass on. So with no air, ultimately when there will be complete vacuum, I will not be able to hear any sound out of this glass jar. Okay. Now, moving on to the third part of the video, another objective that will be covered in the next video.